About isolating for an unknown variable. So you're given a question, they've told us about this circle, and this circle is not to scale, okay? And they've told us C, which stands for the circumference, is 68 centimeters. That means you could almost call it the perimeter, but the distance around the circle. If we go here and go all the way around, right, there we go. I didn't draw. Go all the way around is 68 centimeters, okay? And then what they want to know in this question is they want to know what's r? R is the radius. So from the center, let's assume this is the center, what's the distance from the center to the outside of the circle? And since it's a circle, it'll be the same everywhere. So we have some information. They've given us this, a formula. And it says C, which stands for the circumference of the circle, is equal to pi, which we should talk about what that is. And this little dot here, we could also put brackets, means multiplication, times diameter. Okay, well, diameter is a distance across the circle going through the center, right? We also have another formula. The diameter is equal to 2, and again, that dot means multiplication, 2 times r, which is radius. So we don't have a direct formula. You know, with our circumference, we haven't really directly related it to the radius. So what we're going to do is we're going to talk about how we can set this up mathematically to take information. So when we set up an equation in math, we have our variable, and we have our equal sign, okay? So we write the left side and the right side. So think of this like this is the left side of the equation and this is the right side of the equation. And what separates the two is an equal sign. And in math, this is kind of like balancing a scale. The left side of the equation should always equal the right side of the equation. You ever seen like a teeter-totter? A triangle in the middle? Yep. So whatever we put on one side, we have to put on the other to keep it balanced. As soon as we take something away, we have to take it away from here. If we add something, we have to add it to this side. Okay, we have to keep the scale balanced. So our circumference is equal to pi times the diameter. That's our major formula. We know what the circumference is. They've told us it's 68. So what we can do is we can take that number 68 and we can replace the letter C with it because we know that the circumference is equal to that. This is a concept known as substitution. Okay, so we're going to substitute 68 in for circumference. So 68 is equal to pi times the diameter. Okay, we're still equal. It's still balanced. The left side is still equal to the right side. Now we have a bit of a problem. They don't want to know the diameter. Okay, they want to know the radius. I could do this and isolate. Okay, and isolating would mean figuring out what d is, and then taking d and plug it into a whole nother formula. But I'm going to do something a little different. And then you can choose how you like to do this. But I'm going to substitute again. Okay, I'm going to substitute in for the letter D, diameter. We know that it's equal to 2 times r. Okay, so I'm going to replace the letter D with 2 times r. So when we go to write our next line, just like we did here, when we add new information, we don't write to the right or to the left of the equation. We just start our new equation on the next line when we add information or when we solve something. Reason being is we start writing is equal to 68 is equal to pi times diameter. This gets really confusing. There's way too many equal signs on a line. Okay, so every time we add new information, we just start on a new line. Okay, so we're adding some new information. 68, changing it to black because it's staying the same, is equal to pi times, put that little dot, and now we're replacing d with what? 2, right, times r. Okay, now there's a rule in math, and it doesn't matter what order we multiply things in. Okay, so I could kind of just put brackets around all of these. Brackets means multiplication. We're going to multiply all of these, and I could do this times this first, and then this, or I could do this times this, and then this. It doesn't make any difference to the order we multiply. So I'm going to reorganize this a little, okay? And oh, I forgot to even talk. Pi. Pi is a symbol, so this is on the side, is not part of our equation. I'll write it in green. Pi is a symbol that represents a number that goes on forever. 1, 4, 1, I should know this. 1, 5 something?
Yep.
Yeah, and it goes, and goes. Okay. So it's just holding that place because I want to write all of those numbers in for pi. Okay. So let's kind of reorganize again. So when I change information, I go to the next line again. 68 is equal to pi times 2 times r. Great. We've reorganized. We know we've got a bunch of multiplication. The goal here is to get r by itself. We want the right side or the left, doesn't really matter, but since it's already on the right, we want the right side to only have the letter R. But I have other pieces of information here. I have a pi, or a symbol for pi, and I have the number 2, right? And it's all multiplied by. So I need to start moving things to the other side of the equation, okay? And really what we're doing is eliminating them. But the idea is that when you're moving it over, you're still keeping it balanced, okay? So the first thing I want to move is my pi. And because it's multiplied by, it's usually known as this, on this side, when I move it to the other side, what does it have to become? Do you know?
No.
We use the opposite operation. So what's the opposite operation of multiplication?
Division.
That's right. When we bring it to the left side, we need to divide. So new information means we start on a new line. 68, okay, is going to be divided by pi. We still have our equal signs. We try to keep our equal signs all lined up. And we've moved pi, okay? So pi has now moved to the other side, so it's no longer on this side. All I'm left with is 2 and r. So I just write 2 times r. So I've now moved pi to the other side. Now I can solve for this. What is 68 divided by pi? Well, we'll take out our calculator here. Okay, 68 divided by pi is equal to, it's going to be a really long decimal. So we'll round to the third decimal place because there's a 0 there. 21.645. So I have new information. We've solved 68 divided by pi, so I add a new line. 21 point, and I have no idea what that answer is.
645.
Oh yeah, you're good. 6, 4, 5. Great. Keep our equal signs lined up. All right, equal signs still lined up. And we still have 2 times r on this side. Remember, the goal is to get r by itself. So what's still on this side that's not supposed to be there? What do we got to move?
2.
The 2. 2, it's still multiplied, so when I move to the other side, what operation do we have to use?
You have to use division.
Division again. So we're adding a new line, right? Changing everything, we write a new line, 21.645. And that's going to be divided by 2. Still bring down our equal sign, equals r. Now this is good. Before we calculate this, r is by itself on the right side. This is really, really good. This is our last step. We take this 21.645 and we divide it by 2, and we're going to end up with r is equal to something, right? Remember how I talked about the right side equaling the left? We just got to figure out what that left side is going to be. So we take our 21, and look, my calculator saves it, so I'm going to write that whole number in, divided by 2. 10.82, we'll say. So approximately 10.82. So in other words, okay, now remember I think we wrote this right side in red? I can't remember. Yes, it was. So now the right side is equal to the left side, okay? And that means r is equal to 10.84, okay? So we kind of always write downwards when we're building equations. I know that looks long. You could have skipped a lot of steps, but I wanted to show you everyone. So that means the radius of this is 82, I think? Yeah, 82 centimeters, okay? So that's how you write equations out. Always go to the next line, try to keep our equal signs in the middle, okay?